Hello everyone, my name is Tianyi GU. Today I gonna present our paper about an adaptive software framework for dementia care robots. This is a joint work with Momota Spagam, Naiqian Zhang, Dongping Xu, and Sergey Athana and Dave LaRoche. We are from the University of New Hampshire from United States. So in today's talk, I'm going to talk about the problem we want to solve, introduce our system, and then show our user study, and then conclude the paper. All right. So first, the problem. The question we want to answer is how to better take care of people with dementia disease. All right, dementia disease is a very serious problem nowadays all over the world. Many families suffering from a dementia disease. So the question is, how can we take good care of the family member who has that disease? So there's many aspects. First, we have to take care of their health, meaning we want to make sure they take the correct medication at the correct time. Right, and then we also to make sure they are safe behavior, because we don't want them to wandering out the house at the wrong time. Then many people suffering this problem that their family they can never find their parents, they can never find their family members ever again once they lost them. So many aspects have to take care. So this causing the family member experience a huge care burden. The solution is either you go back to home and then you don't have the chance to work anymore. You have to do a full-time job to take care of your family member, or you hire a health aid, which would causing you about 50,000 a year, or if you want to send your family member to the nursing home, it will cost even more, about 100,000 per year US dollar. So the question we want to answer is, can the robot, along with the current available technologies nowadays, to help with this scenario? If we are able to build a robot that can do the caregiving task, how can we let the lay user, the family member, to easily customize the robot, right? So next, I'm gonna introduce our system, our solutions to this. So first, we design a smart home, which have the AI-powered socially assistive robots. A robot will be used at home to mostly do the caregiving work. And then the robot is connected with a lot of sensors mounted in the house with a local Wi-Fi network. All right, for example, we have a lot of motion sensors to detect if the person is working or trying to pick up something, pick up the medication or not. And then we have temperature sensors, locker sensors, sort of sensors mounted at home. So it's extend the ability of the robots. And then, of course, the family member or the other caregivers can access this local network by access the local network. And then all this together, we are trying to take care of this person with dementia disease. Then we also have a lot of smart devices have put on the person. For example, a smart watch can looking at the heart rate kind of data of the person, which the robot can also access. All right. So next, I'm going to introduce our prototype robot, which is built up on a Pioneer robot, have a movable base along with a laser scanner to localize itself, and then with a gaming laptop on the top, which can doing the planning task on the fly. And also this depth camera mounted, which using to recognize the patient at home. So this is our hardware, and then we using ROS to program the robot. So here's our ROS framework, which is I believe is quite standard nowadays. So we have a planner layer, has the AI planner doing the task planning, and then also this executive to take the sequence of plan of the actions to execute a plan. Then there's a task layer which we designed our hierarchy of the actions. So actually we have a very low resolution in our high-level task actions. For example, we have this search and approach person, which will basically looking around at a house and then trying to find a person at a house. And then this sensor monitor action, which we're monitoring all the sensors mounted at home. It's a remote control, which can giving access to the family members, which is not at home. And then we also have this notify message action, which will say the word that the robot wants to, either warning the patient, trying to let him understand the situations. And then also this phone call action, which can call in for further assistance if the robot itself cannot finish the task. And then there's a scale layer, have a navigation localization mapping kind of scales. And then there's a hardware layer, have the laser, IoT devices, etc. Quite standard. All right. And then for the AI planner, we ask the robot to do some high-level task planning here. So we using ROS plan, which giving us access to leverage the ability of PDDLs. So we can we can define the domain, define the problem file, and then ask planners to give us a plan, available planners to give us a plan. And then, one thing I want to say here, it's very thankful to this techniques. It's very easy to use. So no PDDL expert in the team. I have some background with Heuristic Search, but before this project, I haven't do any PDDL related project. So this is the first time, and then we are able to pick it up fairly quickly, and then design the domain, and then make the system work. All right, so we use PDDL 2.1, and then the planner we use is Contingent FF to give us a contingent plan, which have branches in different scenarios. So what we do is first of all, we design several care protocols. For example, the medication intake protocol, the preventing wandering midnight protocol, kind of protocols. And then for each protocol, we designed a baseline PDDLs. And this is designed together with the clinician and then roboticists together, and then which would meet the requirement of what the robot should do in different scenarios. And then the lay user, and then we enable more importantly, we enable the lay user to customize their PDDLs by filling questionnaires. And one thing I want to mention here is different families suffering from different problems, and then their patient is in different stages. Some of them are already in late stages, meaning they need a lot of care, and then some of them are in early stages, and then the robot have to do less. So the plans should be varied by their customizations. So the customizations here are, to be specific, we delete and add some actions to the domain files, and then also modify the problem file as well. So we designed a system, a generator that can read the lay user's input and then generate a PDDL file accordingly. Right, and then we also customized then this customized PDDL I used for the planner to find a customized plan. So here, example, our baseline planners. For example, we have some notify. We have a notify action, which is the most useful action for the robot because it only can move and then say something. So it will take a message to notify that message. And then this there's a sensor checking, which is an observation action, which will observe the sensor if the sensor is on or off. And then in our initial file, we define the different landmarks in the home, and then we define the messages. It will define the phone messages if it wants to call for extra help. And then there's some initial state, which inside some of them are unknown facts. Initially the robot would be unknown if the sensor is on or off, and then after the observation action, it will read the sensor. So that's pretty much the baseline planner. And then what we do is in the user study, we invite 8 families to looking at this system and then to use it. And so by interacting to use it, as we can see, as I mentioned, so these 8 families suffering from different stages of their family member have this disease. And then we designed the 2 protocols for them to use. One is the medication reminder protocol. If the patient forgot to take the medication at a particular time, say 8 a.m., then the robot will trigger and then find a plan that will try to bring the whole state back into a safe state. And then it's also preventing from wandering out protocol, which is in the late night scenario. If the patient is trying to wandering around and then trying to bring out the house, and then the robot will pick up the information by reading the motion sensors at a house, and then trying to do something to prevent that happening. So to customize the plan, the family members have to fill out this questionnaire form. For example, in the midnight, in the medication reminder protocol, they have to ask if the robot, if the family member cannot find the medication, do they want the robot to find the medication, or do they want the robot to just call them? So once they fill out this form, we can reading this form and then customize the domain file by plugging more actions. For example, we have plugging this find a bottle actions if they want the robot to find where the bottle is. And then there's also extra actions for the following, notify bottle to tell the patient where the bottle is, to call caregiver if they cannot find the bottle. So we also generalized this plug-in PDDL file as a template. So there's wildcard actions, which will take an object, and then there's following actions if that wildcard action is success. There's a following action if that wildcard action is failed. So we are by no means to design any magic here. So all the primitive actions have to be predefined. If the caregiver wants the robot to feed the patient, then if the robot cannot do that feeding actions, then it's not feasible, right? So all the actions, even if we have this wildcard templates, it still have to be predefined actions. Anyway, here's an example of our baseline plan, which will in the medication intake scenario, the robot will try to find a person. If it's not find it, it will call the caregiver. If it's find it, it will notify the message. And then if ask a patient to take the medication, if the patient didn't following the instruction of taking the medication, and then it will, if takes the medication, then the robot will just moving back to its home, and then otherwise it will call the caregiver. So either this action will bring the robot state back into a safe state. So this is a customized plan. Basically, it's a plugging another action, 3 actions, the find the medication bottle action, and then also the notify where the bottle is action, and then the call the caregiver the bottle not found action. So by demo this system in front of the 8 families, we have collected some response. Most of them are quite positive. For example, 5 families say there will be worthwhile to invest this technology into their home, and then 7 of the family says they believe this will be very supportive if they can use this system, and then all 8 family believes that they themselves can set up and then use this technology. So, so to conclude, we proposed a novel software framework for dementia care robots. We proposed a user-driven domain customization approach for the lay user to directly modify the domain files. And then more broadly, the planning enables the user to deeply customize the robot's behavior in this complex HRI setting. And then planning techniques are really easy to use. They are very, very handy for actual world painful problems. With that, I'm gonna stop here and I'm happy to take any questions. Thank you.